M6C4HW12 question 11, following on from question 10, which is all about this graph up here. Calculate the value of the strong force. So we're lather rinse repeating our routine for question 10. Calculate the value of the strong force at the point on the graph labelled with the number 2. So going back to the graph, this point labelled with the number 2 is nearest diameter. That's 4, that'll be 3, that's 2. So let's call that distance, for the sake of making this calculation relatively straightforward, that say that distance on this scale is going to be 2.5 femtometers. So for question 11, we need to be using a distance of r equals 2.5 femtometers times 10 to the minus 15 meters. And then we'll be doing the same routine that we did in the previous question, using Coulomb's law, because the forces are equal in magnitude and opposite in direction at that particular point, in order to have a resultant force of 0. So that's F equals QQ over 4 pi epsilon naught r squared, and that's going to be pretty much identical to what we did in the previous question. 1.6 times 10 to the minus 19 is the charge on a proton. It's 2 protons, so you can either square that, or I like to lay it out a little bit clearer for myself. So proton 1, proton 2, divided by 4 times pi times epsilon naught, 8.85 times 10 to the minus 12, times by the distance between them squared, and that distance is going to be 2.5 femtometers times 10 to the minus 15 meters squared. Don't forget to square, and there's your answer.